Welcome. In this video I'm gonna to give you the basics of trigonometry and let's start. Trigonometry, as the name might suggest, is all about triangles. More specifically, trigonometry is about right-angled triangles where one of the internal angle is 90 degrees. This is the right angle triangle and the angle is 90 degrees. Trigonometry is a system that helps us to work out missing sides or angles in a triangle. A right-angled triangle's reminder. A right-angled triangle has a single right angle. By definition, that means that all sides cannot be the same length. The lengths of these sides are different. A typical right-angled triangle is shown here, and this is, let me write, this is opposite side, this is adjacent side, and this is hypotenuse. We will study the trigonometric functions today. The trigonometric functions are elementary functions, the argument of which is an angle. Trigonometric functions describe the relation between the sides and angles, and this, let it be the angle theta. And applications of trigonometric functions are extremely diverse. For example, any periodic process can be represented as a sum of trigonometric functions, for example, Fourier series. These functions often appear in the solution of different equations and functional equations. So the trigonometric functions include the following three functions. Following six functions. The first one is sine. The second one, cosine, tangent, cotangent, secant and cosecant. For each of these functions, there is an inverse trigonometric function. Trigonometric functions can be defined using the unit circle. So this is our unit circle. Can you see it clearly? Let me draw the circle here. Okay, I think it will be more clear. And this is y, this is x-axis. So the point mxy let it be y1 on the x-axis and let it be 1 on the y-axis. So it is the hypotenuse of this. Here we got right angle triangle. Look please, this is our right angle, let it be alpha, and this is hypotenuse r. This is y, that is equal to sine alpha, and this is x. This is x, and that is equal to cosine alpha. I think it's more clear than this one. Okay. This figure shows a circle of radius r is equal to 1. Okay, here is r is equal to 1, and there is a point mxy on the circle. The angle between the radius vector OM, this is OM, and the positive direction of the x-axis, the positive direction of the x-axis is equal to alpha. Let's find the sine, cosine, tangent, cotangent, secant, and cosecant. The sine of an angle alpha is the ratio of the y-coordinate of the point M to the radius r. Yes, it means that sine is equal to opposite of alpha divided by the hypotenuse r. So the cosine of alpha, cosine of an angle alpha is the ratio of the adjacent leg to the hypotenuse. What is the adjacent? Adjacent leg is this, and the cosine is the ratio of adjacent leg to the hypotenuse. What about tangent? The tangent of an angle alpha is the ratio of the opposite leg to the adjacent leg. Okay, opposite leg to the adjacent leg. The cotangent of an angle alpha is the ratio of the adjacent leg to the opposite. Tangent and cotangent are inverse function, as you see. The secant of an angle alpha is the ratio of the hypotenuse to the adjacent leg. Hypotenuse to the adjacent. What about the cosecant? The cosecant of an angle alpha is the ratio of the hypotenuse to the opposite leg. Hypotenuse to the opposite leg. Let's graph the sine function. So this is the graph of sine function. Y is equal to sine x. The domain is x from 1. The domain x, let me write, domain x from R. And the range is between -1 and 1. As is clearly seen from this graph that while the x and y axis while x and y coordinates are 0, then the sine x gets 0, and here is y is equal to sine x. Okay, this function gets 1 while x is equal to pi over 2. When x is pi, then the result of the function is, as you see, 0. And also when this is, the angle is 3 pi over 2, our result is -1. And when the angle is 2 pi, again the graph gets 0. The result of the function gets 0, and it keeps going. Okay, and the range, the domain can be x, can be all real numbers, and the range only change between -1 and +1, yes, negative and positive 1. So this is the graph of sine function, and let's graph of the cosine function. Here is the graph of cosine function. Could you see the difference between sine and cosine? While sine gets 1, at this point cosine gets 0. Yes? The domain of cosine function is x from real number line, and the range of the cosine function is also between positive and negative 1. So the domain and range of these two functions are the same. But while sine x gets 0, in this point the cosine x gets -1. Okay, while sine gets 0, the cosine gets 1. This is the difference between sine and cosine functions. Next graph is the graph of tangent function. We can write it y is equal to tangent x or just tan x, and these two are the same. So as is clearly seen from the graph that the domain of tangent function can be real numbers such that different from 2k plus 1 times pi over 2. You can see from this graph that this line never touches to pi over 2, never gets pi over 2, yes? But the range is between -infinity and +infinity. So the y-axis, all points on y-axis can be the result of tangent x, but these points cannot be from domain of tangent x. Here is the graph of cotangent function. The domain, as you can see from the graph, that the domain is the real numbers that are not equal to k times pi. It means that it cannot be pi, 2 pi, 3 pi, or -pi, -2 times pi. Okay, the x the point x never gets the chi times pi, but the range can be all points from y. It means that the range of the cotangent x is between negative and positive infinity. So while the tangent function is equal to 0, in this point cotangent is not defined, and while the tangent function is defined, the cotangent function is not defined. So this is the difference between tangent and cotangent functions, and these are the inverse of each other's, by the way. It means that tangent x is equal to 1 over cotangent x. Our next graph is the graph of second function. So the domain of second function, as is clearly seen from the figure, that it can be the real numbers such as different from 2 times k plus 1 over pi, 1 times pi over 2. And the range of this function is, you see, this is -1 and 1. The range cannot get these points. The range can only get 1 to positive infinity and -1 to negative infinity. Yes, this part cannot be from the range of second x. So the range is between starts from negative infinity to -1 and union positive infinity 1 from positive infinity. This is the domain and range or second function. And finally, let's construct the graph of cosecant function. And there is a few differences between the graph of second function and the graph of cosecant function. So as you see, this graph gets 1 at this point, but the graph of cosecant function gets 1 at the angle pi over 2. Here 1, our angle was 0, the graph gets 1. But here, while the angle is pi over 2, the graph gets 1. And also, while the angle is 3 times pi over 2, the graph gets -1. And also, here, we will continue like that. Okay, as is clearly seen from this graph that the domain can be real numbers such that distinct from k times pi. It means that the domain cannot be pi, 2 times pi, 3 times pi, or minus pi. You see, this graph never touches to this point, to this line, and the range of this function is similar to the second function. It cannot get the points between -1 and +1. So the range of cosecant x is from the set -infinity to -1, 1 to positive infinity. This was the domain of the main range is generally the graph of trigonometric functions. Let's continue with trigonometric functions formulas. So in a right angle triangle we have three sides, namely hypotenuse, opposite side which is perpendicular, and adjacent side which is height. The longest side is known as the hypotenuse. The side opposite to the angle is perpendicular, and the side where both hypotenuse and opposite side rests is the adjacent side. So there are basically six laws used for finding the elements in trigonometry. They are called trigonometric functions, which we learned in our previous page, which is sine, alpha, cosine, tangent, cotangent, secant and cosecant functions. So there is some the reciprocal identities are given as from the definition of sine, cosine, tangent, secant and cosecant functions. We get that cosine theta is equal to 1 over secant theta, sine theta is equal to 1 over cosecant theta, tangent theta, as we mentioned before, is equal to 1 over cotangent theta, and secant theta is equal to 1 over cosine theta, and finally cosecant theta is equal to 1 over sine theta. All these are taken from a right angle triangle with the length and base side of the right angle given. We can find out the sine, cosine, tangent, secant, cosecant and cotangent values using trigonometric formulas. The reciprocal trigonometric identities are also derived by using the trigonometric functions. So here we have some trigonometric formulas list. The first is trigonometric formulas involving periodicity identities. Here is the trigonometric formulas involving periodicity identities. Here n is integer, okay, and all trigonometric identities are cyclic in nature. They repeat themselves after this periodicity constant. This periodicity constant is different for different trigonometric identity. For example, tangent, let me write it here, tangent 45 is equal to tangent 225. But this is true for cosine 45 and cosine 225. Refer to the above trigonometry table to verify the values. So, trigonometry formulas involving cofunction identities in degrees. So, trigonometry formulas involving cofunction identities, as is clearly seen that the periodicity of 90 degree, the names change, but the periodicity of 2 pn, the names didn't change, as we mentioned it before. So next formulas, trigonometry formulas involving sum difference identities. Here are the trigonometry formulas involving sum and difference identities. So our first formula is the sum. The sine of x plus y is equal to sine x times cosine y plus cosine x times sine y. And let's continue for cosine x plus y, and this is equal to cosine x cosine y minus sine x sine y. What about tangent x plus y? This is equal to tangent x plus tangent y over 1 minus tangent x tangent y. The sine x minus y is equal to, here was x plus y and here is x minus y, is equal to sine x cosine y minus cosine x sine y. And what about cosine x minus y? It's equal to cosine x cosine y. Here was minus, but here will be plus sine x sine y. And finally, what about the tangent x minus y? It is tangent x minus tangent y over 1 plus tangent x tangent y. Here is multiplication, and here also is multiplication. And next is formulas involving double angle identities. So sine 2 times x. If we want to reduce the degree twice, we will get 2 times sine x times cosine x. And this is also equal to 2 times tangent x over 1 plus tangent square x. Okay. What about the cosine? 2 times x. If we want to reduce the degree, we will get cosine square x minus sine square x. Also, we can write 1 minus tangent square x over 1 plus tangent square x. Also, we can write the third formula, 2 times cosine square x minus 1, and also we can write 1 minus 2 times sine square x. You see, 1, 2, 3, 4, there are 4 formulas. What about tangent 2 times x? If we want to reduce the degree of tangent, we can write to the numerator 2 times tangent x over 1 minus tangent square x. What about the second 2x, second square x over 2 minus second square x. Cosecant 2 times x is equal to secant x cosecant x over 2. Let me write cosecant x over 2. So this is the trigonometry formulas involving double angle identities. So here are the formulas involving half angle identities. So if we have sine x over 2, it's equal to positive negative square root of 1 minus cosine x over 2. What about cosine x over 2? It's equal to positive negative square root of 1 plus cosine x over 2. We get these formulas from these formulas. Okay, and let's continue. Tangent x over 2 is equal to the square root of 1 minus cosine x 1 plus cosine x. Also, we can write for the tangent x plus x over 2 that 1 minus cosine x over sine x. And let's continue. This is equal to, let me continue this process. One minus cosine x, 1 minus cosine x. We will multiply the denominator by the conjugate of 1 plus cosine x. Okay. So the conjugate of 1 plus cosine x is equal to 1 minus cosine x. We multiplied both numerator and denominator by the conjugate of the denominator. So we get here that square root of 1 minus cosine x square, and in the denominator we get 1 minus cosine square x. So from the numerator we get 1 minus cosine x. From the this is the square root of sine square x. Yes, and here we get 1 minus cosine x sine x. Is this two formulas similar? So we proved that tangent x over 2 is also equal to 1 minus cosine x over sine x. Next formulas are the formulas involving product identities. So sine x product cosine y. You see the angles are different. It's equal to sine x plus y plus sine x minus y, and on the denominator we write 2. What about the cosine x cosine y? This is equal to, on the numerator we write cosine x plus y plus cosine x minus y over 2. What about the sine x times sine y? We get that on the numerator we write cosine x plus y minus cosine x minus y over 2. And finally, the formulas involving sum to product identities. What does it mean? It means that if we want to find the sum of sine x and sine y, we will use the product identity. 2 times, let me write it here, 2 times sine x plus y over 2 cosine x minus y over 2. This is like that. So sine x minus sine y is equal to 2 times cosine x plus y over 2 and sine x minus y over 2. Next, cosine x plus cosine y is equal to 2 times cosine x plus y over 2 and cosine x minus y over 2. And our final formula is cosine x minus cosine y. And this is equal to minus 2. See the difference? All these some formulas were the coefficient 2 was positive, but here it's negative. Sine x plus y over 2 sine x minus y over 2. So this was all about trigonometry formulas. To learn more about the topic like trigonometric functions, inverse trigonometric functions, please subscribe to my channel and wait my next video about the solving method of trigonometric equations. Hope you can understand the formulas, the graphs of trigonometric functions, also the definition or what is the trigonometry. And if you have any question, let me know by writing comment below, and see you in our next video. Goodbye.